Hello. So welcome to the last part of our crash course, which is about functions and derivatives. So let's start with the definition of function. Function is a binary relation between two sets that associates each element from the first set to exactly one element from the second set. So if y is the function of x, then for each value of x, there is only one value of y. The opposite is not required to be true. Like for one value of y, you might have more than one value of x. So if we analyze the following graph, then we can see that this graph describes a function, because for each value of x, there is exactly one corresponding value of y. However, if we analyze this graph, then you can see that this is not a function, because for one value of x, you have two corresponding values of y. Okay, so the most common function, I want to say, we're going to discuss a lot during this course, not discuss, rather use a lot, is a linear function. So a linear function is represented by the following equation. So y is equal to a plus b times x, and depending on the values of a and b, it can take different forms. But nevertheless, always a will stand for the value of vertical intercept, or the value of y if x is equal to 0, and b will stand for the slope. So it's derivative of y with respect to x, and it will show you by how many units y will change if x increases by 1 unit. So consider the following example. Here we have y, and here we have x. So if a is positive, then the value of intercept is positive, and if b is positive, then the function is an increasing function with positive intercept. So for this function, a is bigger than 0 and b is bigger than 0. If a is positive but b is negative, then the function has a positive intercept, but the function is a decreasing function. So for this function, a is positive and b is negative. If a is negative and b is negative, then the function will have a negative intercept and the function will be decreasing. So for this function, a is negative and b is positive. And finally, if a is negative and b is positive, then the function will have a negative intercept, but the function will be an increasing function. So here a is negative and b is positive. So we will mostly deal with linear regression models, which have the form of a linear function when the dependent variable is equal to beta 0 plus beta 1 times the value of x, let's say we do this for cross-sectional data, plus the value of the error term. And as you can see, it's a linear function. So you need to know how to interpret the value of constant term and coefficient in front of variable in order to be able to interpret the output of a regression model. But again, we will discuss this a lot. Just keep in mind that linear function is must-have for you. So you should know for sure how to analyze and interpret it. So another function we're going to deal with is quadratic function. To be more precise, it belongs to the family of polynomial functions. And it's also used as a popular specification of a regression model. So the general form is like this: y is equal to a plus bx plus c to the power of x2. Of course, a and b and c can be both positive and negative, and this will affect the shape of the function. So you remember, if a is equal to 0 and b is equal to 0, then y will be equal to, okay, and let's say that c is equal to 1 for the sake of simplicity. Then y will take the form of x to the power of 2, and this function is actually very easy to depict. So it's symmetric, it's always symmetric. It starts here at point corresponding to 0, 0. However, if we assume that a is positive, b is negative, and c is negative, just for fun, then the function will look like this. So first of all, if the value of x is equal to 0, then the intercept will be positive. I mean the intercept with y. Because there is a negative coefficient in front of the linear term, the function will shift to the right. And because c is negative, the parabola will be inverted. So it will look like this. And so on and so forth. So there might be different combinations. I would like to underline that when you run a regression model, you never specify the signs. So another function we're going to use a lot for designing regression models is logarithmic function. So it's described by this equation: y is equal to a plus b times the natural logarithm of x, where a and b are constant. So natural logarithm is the logarithm with base e. In our case, it's the logarithm of x. And basically this expression tells you to what power you need to take e to obtain x. So basically e to the power of n is equal to x, and y is equal to this n. So I would like to underline that this function is defined only if x is greater than 0. So domain of this function is from 0 to infinity. X cannot be negative, because imagine a situation: you want to take e to the power of n and obtain some negative value. And it's impossible, because first of all, e is a positive number. It's approximately equal to 2.71. So this value does not exist and y does not exist if x is negative. So reflecting this, we know that for our function x equal to 0 will be an asymptotic value. I will explain. So if we draw it like this, so we have y on vertical axis, x on horizontal axis, and we assume that y is equal to natural logarithm of x, and the coefficient is positive, then the graph will look like this. So the function will never reach the point where x is equal to 0, to be more precise, y-axis, but it can come very, very close. So this what this function likes when a is positive, and if we assume that a is negative, then the function will be a decreasing function. And it will look like this. So this is for negative a. So that was it when it comes to functions. Of course, like the number of possible function specifications is much bigger than what we have discussed. But as I told you, we are going to discuss only those pieces of theory which we are going to use a lot during this course. Okay, so the next thing to discuss is derivatives of linear function. When you have linear function, y is equal to a plus b times x, the derivative of this function, delta y over delta x, tells you by how many units y will change if x increases by 1 unit. So basically it's a rate of change of this function. It's a slope. And again, if you define the regression model as the model which is linear in variables, so y is equal to beta 0 plus beta 1 times xi plus error term, then beta 1 is equal to derivative of y with respect to x. By how many units y will change if x increases by 1 unit. So beta 1 can be positive, bigger than 0, and this will imply positive causal relationship. Beta 1 can be negative, and this will imply negative causal relationship, and beta 1 can be equal to 0, which will imply no causal relationship. So in general, derivative is the rate of change. Derivative in case of linear function will be constant because the rate of change of the linear function is constant. And when it comes to other possible specifications, it will be a bit different. So I will just going to discuss again very briefly how you calculate remaining derivatives. So as we discussed, as for linear function where a is equal to b times x, dy over delta x will be equal to b. So if we have a constant value of y, like you might recall that this function will look like this when we have y, x, and y is always equal to a regardless of the value of x. then there is no change in value of y. So derivative will be equal to 0. If we discuss logarithmic function, then y is the natural logarithm of x, then dy over dx will be equal to 1 over x. If we discuss polynomial function where y is equal to x to the power of n, then delta y over delta x will be equal to n times x to the power n minus 1. So we shall also discuss the basic rules for calculating the derivatives. So we will omit the product rule and the chain rule because they are not relevant. We are not going to use them. But nevertheless, you should know the following two rules. So the first of all, if y is the combination, linear combination of two functions of x, like let's say y is equal to 2x plus x squared, where this one is f of x and this one is g of x, then derivative of y with respect to x will be equal to derivative of f with respect to x plus derivative of g with respect to x. So this is the first rule, and the second one is that if y is equal to the function of x multiplied by some coefficient, then derivative of y with respect to x will be equal to a times derivative of f with respect to x. Something like this. For instance, if you have y is equal to 10 times x to the power of 2, then derivative of y with respect to x will be equal to 10 times 2 times x. So we keep this coefficient. Finally, we proceed to discussing functions of several variables and partial derivatives. So assume that y is the function of two variables, x and z. For instance, y is equal to 10 plus x squared plus natural logarithm of z. So it's impossible to analyze how y depends on x and z simultaneously. That's why when we calculate partial derivative, we assume that the value of z is constant. So that's why when you calculate the derivative of this expression, this part is equal to 0. This part is equal to 2 times x to the power of 2 minus 1. And this part is equal to 0 because we assume that z is constant. So then the derivative is equal to 2 times x. Analogously, we can calculate partial derivative of y with respect to z. In this case, we will assume that x is constant. So then dy over dz will be equal to 1 over z. And that's it. So an important thing about partial derivatives is that when you calculate partial derivative of dependent variable with respect to one of the independent variables, you assume that other independent variables are constant. So their value does not change. So that was it. I really hope that this crash course was not too crash for you. And see you next week.